Okay, welcome back to Mr. Hassan's Maths channel. I'm now going to be taking on question number 3 from the International A-Level Edexcel Statistics S1 October 2021 exam. And this question here is about stem and leaf diagrams and also box and whisker plots. And the question here tells us that the stem and leaf diagram shows the ages of 35 male passengers on a cruise. And the key for the stem are the tens and the leaves are the units. So 1, 3 represents an age of 13 years. And here they've given us the ages and the number in each of these categories here. And we got to find the median age of the male passengers. Okay, the median is represented by what's called Q2. And to find the median, you take the number of entries, which is 35, and divide it by 2. That tells you where the median is, not what it is. So that's going to be 35 divided by 2. How do I know there's 35? Well, I didn't have to count because they told us there's 35. Now that gives us 17.5. Okay, so that means we're looking for the 18th term. If the number came out as a whole number, like for example, if it came out 17, then I'll look at the 17th and the 18th term and then find the mean of those two. But if it says 17.5, you always round up to the next number, so it's the 18th term, which is the median. That's one way of doing it, and there's other ways of doing it. Some people use n plus 1 over 2, and then that's 17 plus 1 over 2. That's going to give you 35 plus 1 over 2. Sorry, so it's 36 over 2, which is 18. That means it's the 18th term itself. So that's a different method of doing it. This is the method I prefer to stick with because it works well with also the quartiles. So I like to use this method so that we got to pinpoint the 18th term. Now they've given us a number in each of these categories, like in the tens there's 1. So I'm going to put the cumulative frequency here so that I can count along easier. So there's 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 4 is 14, 14 plus 10 is 24. So I know the 18th term is over here. So that's up to the 14th term, that's 15th, 16th, 17th, 18th. So this is the median. So we can say Q2, the median. Q2 is equal to 53. Okay, so I'll put the steps here. I'll write the answer here. So the median Q2 is equal to 53. Okay, it's the 18th term. Okay, it's in the position of the 18th term and its value is 53. Okay, and then part B says show that the interquartile range of these ages is 16. Now we know the interquartile range is equal to the upper quartile minus the lower quartile. So I need to find Q1 and Q3. So let's find Q1. Now Q1 is found by doing n over 4. This is why I like this method. It makes life easier. So we take 35, which is a number, and divide it by 4. 35 divided by 4. And it gives us 8.75. That's 8.75. So that means I'm looking for the 9th term. So the 9th term will be Q3. Okay, and that will be, will be Q1. What I'm talking about? The lower quartile. The 9th term is Q1. So the 9th term, if you look at this, there's 1. I mean, by the time you got here, you're at the 7th term. That's the 8th. That's the 9th. So this is the value of Q1, which is 45. So 45 is Q1. So we need to also find what Q3 is, which is the upper quartile, which is given by 3 times n over 4. So it's basically this number here multiplied by 3, which gives us 26.25. So that means we're looking for the 27th term. You always round it up to the next term. If it's a whole number, if it comes out as a whole number, you take that number and the next one. So for example, if it came out as 26, you'd look for the 26th and the 27th term and find the average of those. But this is a decimal, so you take the next number up, which is the 27th term. So here we've got up to here, we've got the 24th. So that's the 25th, the 26th, and the 27th. So this is going to be the upper quartile. So we can say Q3 is equal to 61. So here we got 61 minus 45. So that's 61 minus 45. That's 16. So the interquartile range is equal to 16. So there's the answer to part B. And then the next part of the question says an outlier is defined as a value that is more than 1.5 times the interquartile range above the upper quartile, or 1.5 times the interquartile range below the lower quartile, sorry. So you're going to have the upper quartile, which you worked out is 61, plus 1.5 times the interquartile range, which is 16. And here you'll have the lower quartile, which is 45, minus 1.5 times the interquartile range. So that will give you the limits. Okay, this will be the upper limit, and this will be the lower limit of where the outliers are going to be. So let's just work that out. So 1.5 times 16, that gives you 24. So it's going to be 61 plus 24, that's 85, and it's going to be 45 minus 24, which is 21. Yeah, so 85 and 21 are the upper and lower limits. So we can say the upper limit is 85, and we can see that there are two numbers, 87 and 88. Therefore 87 and 88 are outliers, so that's 2 so far. So there must be one below it. And we know the lower limit, as we can see here, the lower limit is 21, and therefore we can see, if we look at what's below 21, there's 13, then 27, yeah, 13. There's one number which is 13, therefore 13 is an outlier. Whoops. Outlier. So therefore, a total of 3 outliers. A total of 3 outliers. Spelling it all wrong. Okay, so there's how we can show that. We've shown that the limits of the outliers is 85 for the upper one and 21 for the lower one, and there's 2 numbers above the upper limit and 1 number below the lower limit, so there are 3 outliers altogether. So that's the answer for part 3. Now, so 3 part A, B, and C. Okay, now for part D, it says, on the grid in figure 1 on page 9, draw a box plot for the ages of the male passengers on the cruise. It says, figure 1 on, okay, so this is, let's just do that first. So here we have this box plot, okay, that we have to fill out. I've got all the information that we need from the data that we found already from the box and from the from the stem and leaf diagram, and what we found in terms of the quartiles, upper values, the outliers and so on. All the information we already found in the first couple of parts of the question. So now we got to draw the box plot for the males. All right. Now, so there's a couple of different methods for the whiskers, which we'll talk about in a minute. But first, let's put in the details. We've got in the lower section we have an outlier at 13. So I'll mark that first. That's 10, that's 15, so 13 is going to be over here. That's the outlier from the lower section. And the lower limit is 21. Now this is where there's a bit of a difference of opinion, or different methods of doing so, but I'll just stick to the method that I prefer. So basically, for this method here, you mark the lower limit of the outliers, which is here 21. Okay, that's what I'm going to mark. That's going to be the end of the whisker, the lower whisker. Another method is to take it to the last value, which is before the lower limit, the last value within the lower limit, okay, before the outliers start, which would have been 27. So you could do the whiskers up to 27 if you want to, and that's where you'll see like another set of whiskers in the mark schemes. There will always be 2 sets of whiskers. One will be going to the lower limit, and one will be going to the lowest value within the lower limit. Okay, both methods are perfectly fine. That's why they have both answers. So you don't have to add that extra set of whiskers there. Like some students ask, why has a mark scheme got another set of lines there? Do we have to draw another set of lines? No, there's just a different method. Both of them are acceptable. So I like to go all the way to the lower limit, and some people go all the way to the last value within the lower limit, and that's where they stop their whisker. But it's perfectly fine either way. Anyway, it says Q1 is 45. So the next value I'm going to mark is 45, which is going to be over here. That's going to be where the box starts. That's where the box starts. I'll make that a bit wider. And then Q2 is the median, which is 53. That's 53 over here, so that will go over this part. That'll be 53. And then you have 61 is the upper quartile, Q3, which is going to be over here, 61. So I'll draw that there. And then again, we're going to have the upper limit and the highest value. Then you put the values that are outside the upper limit. So they're going to be the outliers. Okay, so the upper limit again, in the data we have, the highest value before the upper limit is 76. So one method would be to go to 76 and stop the whisker there. Okay, but the other method is to go all the way up to the highest possible value, which is 85. That will be the highest possible value within our limits. Okay, that will be the highest possible value that you can have, so that it won't be an outlier, and that's up to here. Make that a bit shorter. All right, so that will be the upper limit of the whiskers. Okay, if you use that method. And then we're going to have the outliers, which are 87 and 88. So that's an outlier here, and 88 very close to it there. Those are two outliers on this side. So now I'm going to have my box. Okay, the box will be between here and there. That's the box basically. Make it a bit better there. Okay, that's the box. And the whiskers are going to go from here to there, or from here to there. Okay, as I said, there's normally in the mark scheme something that looks like this. So I'm going to mention this because there's a lot of people that ask about this. And they normally have, like, it would be from 27, which is here. Have something at the top of it normally. And the other one is up to 76, which is here. And they'll have something like this. They'll have like another part to it like this. You don't have to draw both of them, of course, either this or this. This is the one where you stop at the lowest value that is within the range of the outliers that's in our data, and you stop at the highest value in the data which is within the limit of the outliers. That's one method of doing it. Okay, and the other method of doing it is drawing a whisker all the way up to the actual limit of your outliers, even if there's no value at that point. And that's the method that I've used here. But either of them are correct, so you don't worry if you see this other one there. It's absolutely fine. Okay, both of them are fine. If you did it either way, it's perfectly fine. Okay, so there's the box and whisker plot for this part D. Then it says part E, comment on any differences on the distribution of ages of male and female passengers on the crew. So you also got this other box plot here, which is for the female passengers. We've just drawn one for the male passengers, and we want to comment on the difference in the distributions of the ages of male and female passengers on the cruise. So we can see from these, there's a couple of things we could maybe mention. One of them is for sure that the average age of the female passengers is higher. The average age is higher compared to the males, because their average age, you can say for the males, if we have to mention some values, Q2 is equal to 53, and for the females, Q2 is equal to, this is Q2, the middle of the box plot, it's going to be 65, 67. 67? Okay, 67. So we can say that the average age of the female passengers is greater. It's worth 1 mark. I think that's perfectly fine, just to mention that. If you could also mention about the females, the ages of the females is more skewed towards the higher ages. Okay, so there are, the number of female passengers which are of higher ages is like more concentrated. You see, there's more of them concentrated in the higher age group than in the lower age groups. Okay, you can see that the median is it's like the difference between the upper quartile and the lower quartile, and the median is much smaller than the difference between the median and the lower quartile. All right, so we can say here, this means 25% of the data is in this area, 25% in this area, and 25% in this area, and 25% in that area. So we can see that there's a large number of people concentrating in this higher age group. We can say that basically. So the average age of the female passengers is greater. I think that's enough for 1 mark here. That should be enough for the mark for this question. That's question part E. And now we're going to move on to part F. Okay. Now part F says, Anja, along with her 2 daughters and a granddaughter, now join the cruise. Anja's granddaughter is younger than both of Anja's daughters. Anja had her 23rd birthday on the day her eldest daughter was born. Okay, so that means she's exactly 23 years older than her eldest daughter. Okay, when their 4 ages are included with the other female passengers on the cruise, the box plot does not change. Okay, so state giving reasons what you can say about the granddaughter's age. All right, now we know the outliers are here, where the age must be from up to 34. Okay, so outliers when the age is less than 34, and outliers would be when the age is greater than 93. Okay, so the outliers when the ages are less than 34 and greater than 93. Now, if the box plot didn't change, there can be no outliers, because if there was if the outliers were included, then it would change by having to add these crosses. So we can say first of all that there will be no outliers. Okay, so there's no new outliers. So that means their ages must conform to that. The ages of all of these people must be more than 34 and less than 93. Otherwise, there would be extra crosses. That's first thing we could say. All right, and then there's four ages. Now, if I add an age in this region here, it's going to change the median. All right, it's going to adjust the median, because, for example, just imagine if I have, for example, the median in this place here, right? And say this particular number is the median. Say there's a number here. This is the Q2. That means there's an equal number on either side of this, equal number of data on either side of this number. Okay, the number of entries to this side and that side are both basically they're equal to each other. If I add a number in this side, then the number of entries on this side becomes more, and the number of entries on this side becomes less. So then we have to adjust the median. It has to move this way. So the median value changes. Okay, it goes to a number on this side, becomes less, right? So if I add a number in this area, okay, then it changes the median. So this would change. But if I add another number on this side, then it balances out again. So if it's greater than the median and one is less than the median, then the median will remain the same. Okay, because you added one on either side, so the number of entries on this side and that side will still be the same, and the place that was in the middle will stay in the middle. Okay, and the same goes for the lower quartile, the median, the upper quartile. So if basically there's 4 people, if the youngest, the granddaughter is in this region here, between these values, and the first daughter is in between these values, and the second daughter is between these values, and the grandmother is between those values, then we will say that none of the quartiles will change. They'll all stay the same, because I've added one on either side of each of them, and they will stay in the same place. So the box and whisker plot will not change. Okay, so that means the granddaughter, the one with the lowest age, must be in this region here, which is between 34 and 56. So we can say that for number 1, we can say that as one of each of the new passengers must be between either, you can say the lower value and, or the lower limit, you could say, between the lower limit and Q1, or between Q1 to Q2, or between Q2 to Q3, or between Q3 and the upper limit. Therefore, the granddaughter, sorry about my bad writing, let me try and adjust my hands. Granddaughter must be between the ages of 34 to 56. 34 to 56. Okay, so that's part 1. And then part 2, we have to deduce the age of Anja. Okay, so Anja, who's the grandmother basically. Now, Anja's age, okay, must be somewhere between 72 and 93. She can't be more than 93. So Anja must be between 72 to 93, because and her daughter, her eldest daughter, the eldest daughter must be between the ages of, this is 67 and 72. Eldest daughter between 67 to 72, right? So Anja is 23 years older than her daughter. Anja's age is 23 plus eldest daughter's age. Okay, she's 23 plus her eldest daughter's age. Okay, so that means if the limit of the eldest daughter is 67, the eldest daughter she can't be less than 67. She can't be less than 67, because she has to be in this third category, because you're going to have the granddaughter, the first daughter, the second daughter, and then this is going to be Anja. All right, so the eldest daughter has to have a range between here. Now, if Anja is 23 years older than her, then her lowest age must be 67 plus 23. So 67 plus 23, which is going to give you 90. So the lowest she can be is 90, and her upper age, okay, well, she can't be one of the outliers, otherwise it will change. So the limit of her age is 93, and the upper limit is 93. So therefore, her age is going to be between 90 and 93 for the box and whisker plot not to change. Okay, so one of them each has to be in each of these categories. Otherwise, these lower quartiles, medians, upper quartiles, okay, they will change. All right, they can't be an outlier. Otherwise, you'd have to add a cross to the outside of those whiskers. So that means there's only 4 of them. The granddaughter must be in this region, the first daughter in this region, the second daughter in that region, and the grandmother in this region. Now, as the grandmother is 23 years older than the eldest daughter, and the eldest daughter can't be below 67, then you have to add 23 to 67. That gives you 90. Right, so she must be at least 90, and the most she can be is 93. Otherwise, she'll be an outlier, and then you'd have to add something to this box and whisker plot. Okay, so there's the answer to part F. I hope that was clear. All right, a lot of people have a problem with this type of this situation of these things like medians, and try to practically understand how it works. A lot of them are good at actually doing the number crunching and working out what things are without understanding what they mean, which is quite a common thing in statistics. But hopefully that gives you an understanding of what they mean and how you could answer such a question. It's not such a daunting question as it might seem to some people in the beginning. I hope that was clear. Other questions which are to do with from this paper of October 2021 of S1 can be found in the playlist that should appear somewhere over here. Other questions which are dealing with this topic of box and whisker plots, stem and leaf diagrams, finding medians and quartiles and such, can be found in this playlist that should appear over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.